This lesson gets a little trickier because we have these things called absolute value inequalities. And as the name would imply, it's an inequality that has an absolute value. So here are two examples. Absolute value of x is less than 2, absolute value of x is greater than 2. Just remember that the absolute value of x equals 2 means that some number has a distance of 2 from 0. So it could be 2 or it could be negative 2 because they both have a distance of 2 from 0. So here you see like the wings and strings for absolute value inequalities, and then let's look at how to solve them. So what you have to do is solve two separate inequalities. You have to solve it as if it were negative, and then again as if it were positive, and remember, you have to flip the sign when you turn it to a negative. So you see here, when they changed it to go from C to negative C, they made the less than sign become a greater than sign, but when they kept it regular C, they kept the sign as it was written. So let's solve one. In order to solve letter A, we have to solve two separate inequalities. One is x plus 7 is less than or equal to 2, and the other one is x plus 7 is greater than or equal to negative 2. So before we solve them, let's look at what happened. I just copied this as it was written, but remember, something that has an absolute value of 2 could be positive or negative. So when I did the negative version, I had to flip the direction of the symbol. So now you just solve them like regular inequalities. So drop a line, minus 7. One inequality is x is less than negative 5. I'm sorry, less than or equal. This one, when you subtract 7, you get x is greater than or equal to negative 9. So if I do my number line, here's negative 9, here's negative 5. Less than negative 5 and greater than negative 9. So that's going to be closed circle, and it's going to be in between them, because in order to be less than or equal to negative 5, I have to go to the left, and in order to be greater than or equal to negative 9, I have to go to the right. So that's a strings. So I can actually write this as a combined inequality if I wanted to. I would write it negative 9 is less than or equal to x, which is less than or equal to negative 5. That's the advanced way to write it. The other way to write it is just to put an and symbol in between your two solutions, and you circle that. So either one is okay. Now when you look at letter B, your instinct would say, okay, so at 8x minus 11 is less than 0, 8x minus 11 is greater than negative 0, which is just regular 0. But can the absolute value of a number be less than 0? No, it can't, because less than 0 means negative, and absolute value answers are not negative. So we don't need to do anything for this. We just have to use our memory of absolute values and say that this has no solution. So I'm not going to bother splitting it up. And if you did actually split it up, you'd get two numbers that actually, when you plugged them in, would be what we called extraneous in an earlier lesson. I'd like you to try letters A, B, and C in example 2 on your own. As you can see, letter C is a little more complex, so if you're stumped on it, just kind of play along. I would love for you to give it a try, but if you can't do anything, you can just wait until I pop up the answers. Alright, so letter A and letter B, pretty straightforward. Okay, so you just split up into your two inequalities. Don't forget to flip the direction of the symbol when you change it to a negative. And then you just solve. Same thing over here. I did have to flip the symbol at the end because I went from negative m to positive m, so they actually both had to flip right here. So this one flipped and then it flipped back. but you just follow the rules. And so I got this. So fix any mistakes in letters A and B. Now let's talk about letter C. So if you had anything wrong in letter C, please erase it and fix it. Let's talk about the steps. So the first thing that I did was I had to move the 1. You can't actually split the inequality up until it's totally by itself. If you notice in all the other examples, the inequality had no other numbers on the side with it. So first I moved the 1 just like regular inverses. Then I moved the 4, so I subtracted 1, got 20. Then I divided by 4 and I got 5. Now that the absolute value is totally by itself, now I can split it up. So this gives me x is greater than 5. This gives me x is less than 0. When I graph it, it's a wings, so they're all wings, so they were all or statements. So give yourself a pat on the back if you were able to get letter C. If you weren't able to get letter C, don't worry. You're still good at inequalities. Letter C was definitely a tricky one. All right, now we have this other word that you've actually kind of used a little last year. It's called the absolute deviation. Now you actually use this when you did mean absolute deviation back in 7th grade, or the MAD as the abbreviation is, and it's just like the absolute value distance from a given number. And in like statistics and politics, they kind of call it like the margin of error. So like for example, when they're doing a poll about voter preferences, they might say it has a margin of error of 2%. So they could be off a little 2% on the higher end, or they could be off a little by 2% on the lower end. So they give themselves a little range on either side. And that's what the absolute deviation in a sense is. So let's scroll to example 3. You're buying a new computer. The table shows the prices of computers in a store advertisement. You are willing to pay the mean price with an absolute deviation of at most $100. So you're willing to go up $100 or go down $100, but you're not willing to really go that much more off the mean price. So let's break this down. We have to find how many computer prices meet this condition. So the first thing we actually have to do is pause for a second and find the mean, right? We have to find the average, because then we can figure out what is 100 above the mean and what is 100 below the mean. So pause the video right now and calculate the mean of these computer prices. So I did the calculations and I got that the mean is $664. So the absolute deviation means you're willing to go up $100 and down $100. So I'm willing to go from $564 all the way up to $764. So the question is, how many of the computers meet your conditions? So let's see, not this one, 650, that will work. 660. 450 is too low, 725 works, 750 works, 370 is too low, 670, 650, and 825 is too high. So 1, 2, 3, 4, 5, 6. So 6 computers. That's an S at the end. All right. Now, if you have any questions, write them down and ask me when you come to class.